So today, we're going to do something a little different. We're going on a journey not just with our eyes, but with our ears, all the way out to the outer solar system. We're going to listen to the truly haunting sounds that have been captured from the moons of Jupiter. It's an incredible story about invisible energy, deep space probes, and how scientists are basically translating the language of physics into something we can actually hear.
I mean, just think about that question for a second. What does another world sound like? It sounds like something straight out of science fiction, doesn't it? You might imagine wind whistling across some alien desert, or maybe the strange calls of unknown creatures. Well, the reality is every bit as fascinating, even though it has nothing to do with air or sound as we know it. And our set of ears in the Jupiter system is NASA's Juno spacecraft. Now, its main job is to study the gas giant Jupiter itself, but its mission got extended, and that's brought it incredibly close to some of Jupiter's most famous moons. And luckily for us, it's packed with instruments that can pick up the signals that are, in a way, the true voices of these distant worlds.
Okay, our first stop is Europa. And if you follow space exploration at all, you know this moon. It's famous for that gigantic, liquid water ocean that we think is sloshing around right under its icy shell. It's one of our top candidates in the search for life, so you can bet that any data we get from Europa is super exciting.
So picture this. It's September 29th, 2022, and Juno just screams past Europa, getting as close as 220 miles. In space terms, that is unbelievably close. And as it flew by, its waves instrument was switched on, listening. Not for sound waves, of course, but for tiny disturbances in the electric and magnetic fields all around the moon, basically sampling Europa's plasma environment. All right, so that's the big question, right? What did Juno actually find? When scientists got that data back to Earth and started processing it, the answer they uncovered was, well, it was both really eerie and kind of beautiful. But to really understand what Juno captured, we first have to get into how you can listen to space at all. Because remember, space is a vacuum. There's no air for sound to travel through like it does here on Earth.
What Juno detected are something called plasma waves. And don't let the name throw you off. The best way to think about them is like ripples. Not in water, but in that super hot electrically charged gas, the plasma, that fills all the space around Jupiter and its moons. To our ears, these waves are completely and totally silent.
So how in the world do we hear them? Well, scientists use this really cool process called data sonification. They take the raw data, all the frequencies that Juno's instrument picked up, and they shift those frequencies way, way down so they fall into the range of human hearing. It's kind of like taking a song recorded at a pitch so high only a dog could hear it, and then slowing it down until you can finally make out the melody. And the result? Well, according to Scott Bolton, who's the head scientist for the entire Juno mission, he says it's a wild ride. The audio they created from Europa is full of these strange chirps and whistles. He says it sounds just like a soundtrack from a classic sci-fi movie. And honestly, he's not wrong. But wait, the story does not end at Europa, not even close. Because as it turns out, a flyby of another one of Jupiter's moons, Ganymede, revealed something even more dramatic. This really is a tale of two very, very different moons.
So while Europa gave us this kind of haunting ambient soundtrack, Ganymede delivered something else entirely. It wasn't just a hum or a whistle, it was the signature of a massive electromagnetic power surge. Basically, an invisible explosion of pure energy. And this huge difference all comes down to what makes Ganymede so incredibly special. First off, it's not just a moon. It's the largest moon in our entire solar system. It's even bigger than the planet Mercury. But here's the real kicker. Ganymede is the only moon we know of that generates its own magnetic field. This field creates its own little protective bubble, a mini magnetosphere, that's nested right inside Jupiter's colossal one. And that unique setup, it creates some seriously extreme physics. So, back on June 7th, 2021, when Juno flew right through Ganymede's one-of-a-kind magnetic environment, what did it find that was so profoundly different from what it heard at Europa? All right, get ready for this, because the answer is a number that is just staggering. Juno basically flew through an invisible storm of almost unimaginable power. 1 million. For a brief moment, as it crossed a very specific boundary in Ganymede's magnetosphere, Juno detected a 1,000,000-fold increase in the power of the plasma waves.
I mean, that is just a colossal amplification of energy happening in the space right next to this moon. So what caused it? The scientific culprit is a very special kind of plasma wave. They're called electromagnetic ion cyclotron waves, or just EMIC waves for short. And it turns out that in the very unique conditions created where Ganymede's magnetic field meets Jupiter's, these waves can get amplified to an absolutely incredible degree. It's the perfect storm for invisible energy. So we have this haunting, eerie song from Europa, and then this ridiculously powerful energy surge from Ganymede. What do these totally different voices actually tell us about the Jupiter system as a whole? Let's just break it down real quick. At Europa, those sounds are helping us understand the complex dance going on between the moon's thin atmosphere and Jupiter's mighty magnetosphere. But at Ganymede, the data is showing us something else entirely, how a moon with its own magnetosphere can act like a giant natural particle accelerator, creating these extreme energy events on a massive scale. Okay, but why does any of this matter? I mean, they're just invisible waves, right? Well, it matters because these waves are incredibly powerful. They grab charged particles in the plasma, they heat them up, and they cause them to rain down onto the icy surfaces of these moons. And over millions of years, this constant shower of energy could be fundamentally changing the chemistry on the surface, a process we desperately need to understand, especially if we're looking for life at Europa. So in the end, when we listen to these sonified signals from Jupiter's moons, we have to remember what we're really hearing. It's not an alien broadcast. It's not a secret message. We are listening to the direct result of the raw, fundamental physics of distant worlds, the crackle and hum of magnetic fields and charged particles interacting on a planetary scale. And all of this just leaves us with the biggest question of all, doesn't it? As we keep exploring with missions like Juno and the upcoming Europa Clipper, what other incredible secrets and what other strange new songs are Jupiter's moons just waiting to sing for us?